1947. Protesters have been occupying the site of the proposed mine since January 2021. 148, 144 applications. Pie chart of how much lithium was used and in what way globally in 2020. 149. Ceramics and glass, 18%. Batteries, 65%. Lubricating greases, 5%. Continuous casting, 3%. Air treatment, 1%. Polymers, 3%. Primary aluminium production, pharmaceuticals, other, 5%. Batteries. In 2021, most lithium is used to make lithium-ion batteries for electric cars and mobile devices. Ceramics and glass. Lithium oxide is widely used as a flux for processing silica, reducing the melting point and viscosity of the material and leading to glazes with improved physical properties, including low coefficients of thermal expansion. Worldwide, this is one of the largest use for lithium compounds. 150, 151 glazes containing lithium oxides are used for ovenware. Lithium carbonate, Li2CO3, is generally used in this application because it converts to the oxide upon heating. 152 electrical and electronic. Late in the 20th century, lithium became an important component of battery electrolytes and electrodes, because of its high electrode potential. Because of its low atomic mass, it has a high charge and power-to-weight ratio. A typical lithium-ion battery can generate approximately 3 volts per cell, compared with 2.1 volts for lead acid and 1.5 volts for zinc carbon. Lithium-ion batteries, which are rechargeable and have a high energy density, differ from lithium metal batteries, which are disposable. Primary batteries with lithium or its compounds as the anode. 153, 154. Other rechargeable batteries that use lithium include the lithium-ion polymer battery, lithium-ion phosphate battery, and the nanoion battery. Over the years, opinions have been differing about potential growth. A 2008 study concluded that realistically achievable lithium carbonate production would be sufficient for only a small fraction of future PHEV and EV global market requirements, that demand from the portable electronics sector will absorb much of the planned production increases in the next decade, and that mass production of lithium carbonate is not environmentally sound. It will cause irreparable ecological damage to ecosystems that should be protected, and that Li-ion propulsion is incompatible with the notion of the green car. 54. Lubricating greases. The third most common use of lithium is in greases. Lithium hydroxide is a strong base and, when heated with a fat, produces a soap made of lithium stearate. Lithium soap has the ability to thicken oils, and it is used to manufacture all-purpose, high-temperature lubricating greases. 18, 155, 156. Metallurgy. Lithium, for example as lithium carbonate, is used as an additive to continuous casting mold flux slags where it increases fluidity. 157, 158. A use which accounts for 5% of global lithium use. 2011. 53. Lithium compounds are also used as additives, fluxes, to foundry sand for iron casting to reduce staining. 159. Lithium, as lithium fluoride, is used as an additive to aluminium smelters, Hall-Héroult process, reducing melting temperature and increasing electrical resistance. 160, a use which accounts for 3% of production. 2011. 53, when used as a flux for welding or soldering, metallic lithium promotes the fusing of metals during the process. 161, and eliminates the forming of oxides by absorbing impurities. 162, Alloys of the metal with aluminium, cadmium, copper and manganese are used to make high-performance, low-density aircraft parts. See also lithium aluminium alloys. 163. Silicon nanowelding. Lithium has been found effective in assisting the perfection of silicon nanowelds in electronic components for electric batteries and other devices. 164. Lithium using flares and pyrotechnics is due to its rose-red flame. 165. Pyrotechnics. Lithium compounds are used as pyrotechnic colorants and oxidizers in red fireworks and flares. 18. 166. Air purification. Lithium chloride and lithium bromide are hygroscopic and are used as desiccants for gas streams. 18. Lithium hydroxide and lithium peroxide are the salts most used in confined areas, such as aboard spacecraft and submarines, for carbon dioxide removal and air purification. Lithium hydroxide absorbs carbon dioxide from the air by forming lithium carbonate, and is preferred over other alkaline hydroxides for its low weight. Lithium peroxide, Li2O2, in presence of moisture not only reacts with carbon dioxide to form lithium carbonate, but also releases oxygen. 167, 168. The reaction is as follows: 2 Li2O2 plus 2 Co2 2 Li2 Co3 plus O2. Some of the aforementioned compounds, as well as lithium perchlorate, are used in oxygen candles that supply submarines with oxygen. These can also include small amounts of boron, magnesium, aluminium, silicon, titanium, manganese, and iron. 169. Optics. Lithium fluoride, artificially grown as crystal, is clear and transparent and often used in specialist optics for IR, UV and VUV, vacuum UV, applications. It has one of the lowest refractive indexes and the furthest transmission range in the deep UV of most common materials. 170. Finely divided lithium fluoride powder has been used for thermoluminescent radiation dosimetry. TLD. When a sample of such is exposed to radiation, it accumulates crystal defects which, when heated, resolve via release of bluish light whose intensity is proportional to the absorbed dose, thus allowing this to be quantified. 171. Lithium fluoride is sometimes used in focal lenses of telescopes. 18. 172. The high nonlinearity of lithium niobate also makes it useful in nonlinear optics applications. It is used extensively in telecommunication products such as mobile phones and optical modulators, for such components as resonant crystals. Lithium applications are used in more than 60% of mobile phones. 173. Organic and polymer chemistry. Organolithium compounds are widely used in the production of polymer and fine chemicals. In the polymer industry, which is the dominant consumer of these reagents, alkyl lithium compounds are catalysts /initiators. 174. Ionic polymerization of unfunctionalized olefins. 175, 176, 177. For the production of fine chemicals, organolithium compounds function as strong bases and as reagents for the formation of carbon-carbon bonds. Organolithium compounds are prepared from lithium metal and alkyl halides. 178. Many other lithium compounds are used as reagents to prepare organic compounds. Some popular compounds include lithium aluminium hydride, Nil4, lithium triethylborohydride, N-butyllithium and butyllithium. The launch of a torpedo using lithium as fuel. Military. Metallic lithium and its complex hydrides, such as Li, Al-H4, are reused as high-energy additives to rocket propellants. 36. Lithium aluminium hydride can also be used by itself as a solid fuel. 179. The Mark 50 torpedo stored chemical energy propulsion system, SEPS, uses a small tank of sulfur hexafluoride, which is sprayed over a block of solid lithium. The reaction generates heat, creating steam to propel the torpedo in a closed Rankine cycle. 180. Lithium hydride containing lithium-6 is used in thermonuclear weapons, where it serves as fuel for fusion stage of the bomb. 181. Nuclear. Lithium-6 is valued as a source material for tritium production and as a neutron absorber in nuclear fusion. Natural lithium contains about 7.5% lithium-6, from which large amounts of lithium-6 have been produced by isotope separation for use in nuclear weapons. 182. Lithium-7 gained interest for use in nuclear reactor coolants. 183. Lithium deuteride was the fusion fuel of choice in early versions of the hydrogen bomb. When bombarded by neutrons, both 6Li and 7Li produced tritium. This reaction, which was not fully understood when hydrogen bombs were first tested, was responsible for the runaway yield of the Castle Bravo nuclear test. Lithium deuteride was used as fuel in the Castle Bravo nuclear device. Tritium fuses with deuterium in a fusion reaction that is relatively easy to achieve. Although details remain secret, lithium-6 deuteride apparently still plays a role in modern nuclear weapons as a fusion material. 184. Lithium fluoride, when highly enriched in the lithium-7 isotope, forms the basic constituent of the fluoride salt mixture LiFeBF2 used in liquid fluoride nuclear reactors. Lithium fluoride is exceptionally chemically stable, and LiFeBF2 mixtures have low melting points. In addition, 7Li, B, and F are among the few nuclides with low enough thermal neutron capture cross-sections not to poison the fission reactions inside a nuclear fission reactor. Note 3, 185. In conceptualized, hypothetical, nuclear fusion power plants, lithium will be used to produce tritium in magnetically confined reactors using deuterium and tritium as the fuel. Naturally occurring tritium is extremely rare, and must be synthetically produced by surrounding the reacting plasma with a blanket containing lithium, where neutrons from the deuterium-tritium reaction in the plasma will fission the lithium to produce more tritium 6Li and N4He plus 3H. Lithium is also used as a source for alpha particles, or helium nuclei. When 7Li is bombarded, bixarated protons 8B is formed, which almost immediately undergoes fission to form two alpha particles. This feat, called splitting the atom at the time, was the first fully human-made nuclear reaction. It was produced by Cockcroft and Walton in 1932. 186. 187. Injection of lithium powders is used in fusion reactors to manipulate plasma material interactions and dissipate energy in the hot thermonuclear fusion plasma boundary. 188. 189. In 2013, the U.S. Government Accountability Office said a shortage of lithium-7 critical to the operation of 65 out of 100 American nuclear reactors places their ability to continue to provide electricity at some risk. Castle Bravo first used lithium-7 in the Shrimp. Its first device, which weighed only 10 tons, and generated massive nuclear atmospheric contamination of Bikini Atoll. This perhaps accounts for the decline of used nuclear infrastructure. 190. The equipment needed to separate lithium-6 from lithium-7 is mostly a Cold War leftover. The U.S. shut down most of this machinery in 1963, when it had a huge surplus of separated lithium, mostly consumed during the 20th century. The report said it would take 5 years and $10 million to $12 million to re-establish the ability to separate lithium-6 from lithium-7. 191. Reactors that use lithium-7 heat water under high pressure and transfer heat through heat exchangers that are prone to corrosion. The reactors use lithium to counteract the corrosive effects of boric acid, which is added to the water to absorb excess nutrients. 191. Medicine. Lithium is useful in the treatment of bipolar disorder. 192. Lithium salts may also be helpful for related diagnoses, such as schizoaffective disorder and cyclic major depression. The active part of these